بسم الله الرحمن الرحيم الحمد لله والصلاة والسلام على رسول الله. These are some exercises about section 7.8 improper integrals. Determine whether the integral is convergent or divergent. Evaluate integrals that are convergent. So we have here infinite limit from negative infinity to negative 1. By definition, we write it limit when t approaches negative infinity of integral from t to negative 1 x to the power negative 1 over 3 dx. Notice that this function is not continuous at 0, but 0 is not in this interval. From negative infinity to negative 1, this is just an infinite interval, and the function is continuous in this interval. So let us find this integral. When we evaluate the integral, we will have x to the power negative 1 over 3 plus 1, so 2 over 3, over 2 over 3, all times 3 over 2, from t to negative 1. So it would be 3 over 2 times negative 1 to the power 2 over 3, that's just 1, minus 3 over 2 times t to the power 2 over 3. So we continue here. This is the limit. T approaches negative infinity of 3 over 2 minus 3 over 2 times t to the power 2 over 3. If we replace t by negative infinity, then negative infinity to the power 2 would be infinity. Cube root of infinity is infinity. So this is negative 3 over 2 infinity. Everything will give you infinity. It's negative because we have infinity from here, negative sign. There is a negative sign. So the limit would be negative infinity, and the integral is divergent. Don't forget that t to the power 2 over 3 is just the third root of t to the power 2. You can write it like this, or 2 inside. Well, here we have an infinite limit. So we write it limit when t approaches infinity of 1 over t 1 over x squared plus 4 dx. And the integral of 1 over x squared plus 4 is half tan inverse x over 2 by the formula from 1 to t. So we have half tan inverse t over 2 minus half tan inverse half. And tan inverse t over 2, if we replace t by infinity, then tan inverse infinity, as we know, is pi over 2. Limit tan inverse when t approaches infinity is pi over 2. If you don't know how, just go to the lecture video about section 7.8, negative half, and tan inverse half. You can just find it by calculator. Tan inverse half, but remember to be in the radian mode. Okay, and that would be the answer. You can Yeah, if I use the calculator, it gives 0.46, so I will just write it tan inverse half, so pi over 4 minus half tan inverse half. That's the exact answer. So this integral is convergent. This is again into a limit, infinite limit. So I use limit when t goes to infinity, integral from 0 to t. You can write it like this, or I can just write it 1 plus x to the power negative 1 over 4 dx. And 1 plus x to the power negative 1 over 4, when integrated, we add 1. So it would be 3 over 4 over 3 over 4, or times 4 over 3 from 0 to t. So we will have 4 over 3 times 1 plus t to the power 3 over 4 minus, when I replace x by 0, I will have just 4 over 3. Now if I put t infinity, then 1 plus infinity infinity to this power infinity times everything. So it will give infinity, and the integral is divergent. This is again an infinite limit, and we define it as limit when t goes to negative infinity, and we replace negative infinity by t. Now to find this integral, I let u equals 4 minus x squared by substitution, and du would be negative 2x dx. So it would be integral from t to negative 3. I need negative 2, so 1 over negative 2 du over u. So it would be negative half ln absolute value of u, and from I can write it negative half ln 4 minus x squared, and I go back to x squared to replace x from t to negative 3. If you want, you can change the limits of the integral, but I will do it like this. So I have negative half ln, if I replace x by negative 3, 4 minus 9, negative 5, absolute value, it would be 5, minus, so it would be plus half ln absolute value of 4 minus t squared. So I would have limit t goes to negative infinity, approaches negative infinity, of negative half ln 5 positive half ln absolute value of 4 minus t squared. Now if I replace t with negative infinity, then I'll have here 4 minus infinity, so it's negative infinity, absolute value infinity, ln of infinity is infinity, so everything would be infinity, and the integral is divergent. Again, this is an infinite limit. Write it limit when t approaches infinity, 1 to t, and let me distribute this. So x squared over x to the power 4 would be x to the power negative 2 plus x to the power negative 3 plus 1 over x to the power 4, which is x to the power negative 4 dx. So it would be limit t goes to infinity of x to the power negative 1 over negative 1 plus x to the power negative 2 over negative 2 plus x to the power negative 3 over negative 3. All of this from 1 to t. So it would be limit when t approaches infinity of negative 1 over t minus 1 over 2 x t square instead of x square. I'm taking the power, taking everything down to make the power positive and replacing x by t at the same time. Here I have negative, the 3 is below, and I'll have t to the power 3 minus. Now replacing x by 1, I'll have negative 1 minus half minus 1 over 3. If I replace t with infinity, 1 over infinity, 1 over infinity, this would be all 0. And the answer would be 1 plus half plus 1 over 3, which is 11 over 6. So this integral is convergent. Well, this is again an infinite limit. I write it limit when t approaches infinity from 0 to t e to the power x over 1 plus ex to the power 2 dx. I will let u equals 1 plus ex. So du would be ex dx, and the integral would be integral of du over u square. And this, the integral of u to the power negative 2 is negative 1 over u, which is, I will write it as negative 1 over 1 plus ex, because u is 1 plus ex. And then I replace x from 0 to t. So I will have negative 1 over 1 plus e to the power t minus negative 1 over 1 plus e to the power 0, which is 1. Now e to the power infinity is infinity, negative 1 over infinity is 0, minus times minus is plus. So the answer is half, and the integral is convergent. Limit when t approaches infinity from 1 to t of 1 over x times x plus 1 dx. Now 1 over x times x plus 1, I can write it a over x plus b over x plus 1. And to find a, I can replace x by 0 after cancelling x here. So a would be 1. And replace x by negative 1, cancelling x plus 1. So 1 over negative 1, b is negative 1. So this would be limit t approaches infinity of one integral of 1 over x is ln absolute value of x minus ln absolute value of x plus 1 from 1 to t. So this would be limit t approaches infinity of ln t is positive because it's approaching infinity, minus ln of t plus 1, minus ln 1, that's 0, plus ln 1 plus 1, 2. Now, I have here ln infinity, which is infinity, minus ln infinity, which is infinity. Infinity minus infinity is an indeterminate form. So I will write it ln t over t plus 1, because ln a over b is ln a minus ln b. And now this would be t. If I replace t by infinity, it would be infinity over infinity. So limit ln t over t plus 1 when t approaches infinity would be equal to ln limit when t approaches infinity of t over t plus 1. And here we have infinity over infinity, so I can use L'Hopital's rule and write it. The derivative of t is 1, the derivative of t is also 1. So this is just 1 over 1, and ln 1 is 0. So this limit would be 0 using L'Hopital's rule, and the answer would be ln 2, and the integral is convergent. Again, this is limit when t approaches infinity from 2 to infinity y times e to the power negative 3y dy. I can solve this integral by using the table, the quick method in integration by parts. U is y, derivative of y is 1, then 0. E to the power negative 3y is dv. The integral is e to the power negative 3y over negative 3. And the integral again is e to the power negative 3y over 9. Negative 3 times negative 3 would be 9. Then I multiply this times this and this times this. Here I do not write infinity, I write t. So it would be limit t approaches infinity of negative 1 over 3 y e to the power negative 3y, negative 1 over 9 e to the power negative 3y from 2 to t. So it is limit t approaches infinity of negative 1 over 3 t e to the power negative 3 t minus 1 over 9 e to the power negative 3 t minus negative 1 over 3 2 e to the power negative 6 minus, it would be plus 1 over 9 e to the power negative 6. So this is okay, I'll keep it like this. And then I have minus, and this is minus 1 over 3 minus 9. Yeah, like this is better. So here I replaced by 2, first number by 2, then Yeah, I replace here by 2, so this would be negative. So now if I replace t by infinity, e to the power negative infinity is 0. E to the power negative infinity is 0. And the answer would be 2 over 3 e to the power negative 6 plus 1 over 9 e to the power negative 6. And I can write it 7 over 9 e to the power 6. And the integral is convergent. This is limit when t approaches infinity, integral from 1 to t ln x over x dx. I take u equals ln x, du would be 1 over x dx. This would be the integral of u du. So it's u square over 2, which is ln x square over 2. So from 1 to t, I'll have ln x square over 2 from 1 to t. So I'll have ln t square over 2 minus ln 1 is 0. So now if I replace t with infinity, ln infinity is infinity. So the answer is infinity. And this integral is divergent. I'll stop here and continue in another video.